So we discussed Module 5 on Tuesday, Module 10 today, and I want you to complete the test at least, along with whatever other homework or learn items you want to do for Modules 5 and 10 by Monday next week. So just keep that in mind. I'm looking for at least those tests. You can do however much more you want of the learn and homework sections. I want to go over some examples of Module 10 with you so that you have some familiarity before you leave today, and then you can continue to explore on your own. Talking about polynomials, and 10.1 is about adding and subtracting them. And by polynomial, we just mean like a grouping of terms with some of them having what we call coefficients or numbers in front of the variables, their powers, plus minus between the terms, and maybe a constant term at the end without variable. And so we have to keep in mind what we talked about as far as identifying which ones are alike to understand how we're going to operate with them. So with the first example you see on the front page, this is adding polynomials. Let's look at that one. Add 2x squared minus 3x plus 5. That's grouped like this as if it's one polynomial, and then the next one plus negative 3x squared minus 8x minus 6. So the two polynomials we're looking at have 3 terms each. This one has 3, this one has 3. Just as a kind of overview of what we're looking at, this one's got a square term, this one's got a first power term, this one's got a constant term. And we have some similar stuff there that we'll identify as alike. What I would immediately start with is just asking yourself, does plus change the sign on any of those things? No. A negative would change the sign. A subtraction sign would be distributed, but plus we can just keep those signs. So I would simplify your view by writing down these polynomials without the parentheses. Plus all of those means I can just keep their signs as is, like that. One more paper. Oh, the notebook, yeah. I have started to abbreviate your packet. So if you want one of these, let me know. Which ones are alike? Yeah, those 2x squared and negative 3x squared are alike. What will they combine to? 2 minus 3, we can think of it, or 2 plus negative 3. That's different to 1. 3 having the sign of negative, 3 being larger. And I'm just going to write a 1 for our accounting to start with. Then what else is alike? These two both have negative signs. So what do we have with the x? Minus, negative, and all told 11. We'll combine those by addition since they're the same sign. Negative 11x, and then looks like we've got some constant terms. So we can treat those as alike. What do we have at the end? 5 minus 6. combined for -1. Then, if you have ones in front of your variables, simplify the final writing of it by dropping those ones, but not this one. That one's important. This is a constant term. I can take it away from a term that has a variable placeholder in it, but I couldn't take it away from the constant place. Nothing to hold its place next to it. We got -x squared minus 11x minus 1. For that example, anything that's given you pause or trouble in those steps? And you want me to go back over, clarify? Yeah. So the next example involves subtraction. Yeah, this is where we want to stop. So like we said, Tuesday, and in general, when we're looking at variable expressions, when we get to a point where terms have different powers, like these two, or don't have the variables, this is unlike either of these, since it's not got a variable. We want to resist the temptation to try to do anymore, or combine those anymore. Let's subtract as you see here, 4x squared minus 3x plus 2 minus 3x squared minus x minus 5. So this time we have minus in between the two polynomials. So we have to be a little bit more careful about the signs on everything in our second polynomial that coming after the minus. With the first one, it's just got an understood positive out here. So we can just write it down without the parentheses. But then the second one, we need to treat it as if we're multiplying each item by a negative. So this one being positive means the result would be negative. Negative times negative, positive. Negative times negative, positive. Now we can go through like we did here, identify those that are alike. Got a square term and a square term, 4 minus 3 for 1, x squared. Then we've got our x terms here, -3 plus 1. You can read that one. 1x is -2. And then finally 2 and 5, both positive, combined for 7. Drop that 1 in front of variable term. And looks like we have everything that is alike combined. So we're done there. This one here came from the squiggly line pieces, -3x plus, if it doesn't have a number, just treat it as if there's an understood 1 there. It's a -3 combined with +1, -3 plus 1. Difference is 2. 3 has the sign of negative. 3 is higher. That's why it's negative in the end. Anything else you're wondering about in those steps? Let's look at one of the practice problems, that first one. Actually, let's look at the second one. No, the first one's fine. 9 x cubed, notice that has a different power on it, is 3 this time, minus x plus 5, add x cubed plus 3x squared and 8x plus 8x. We got addition, so we can just drop that set of parentheses, no change of signs needed. So I'm going to rewrite all of this without my parentheses. And what's alike? This one, these two, and what do they combine to? 9 and 1 for 10, x cubed. So those are the ones we just looked at. Now, anything like that you see left? You're looking at this one? Yeah, we used those that I underlined. So you can kind of just ignore those after you've used them. Of what we have remaining, do we have any that look alike? What I would recommend is that you kind of scan across your expression and come to the next highest power term. So that one's got a square on it, a 2 on the power, right? Ask yourself, do any of the other terms have that? No. None of the other ones have power of 2. So that means that one just stays the same, 3x squared. Then, once you check that off, go to your next power, and that's x. Do we have any other x? The first power or regular x term? 8x. So negative 1x plus an 8x is 7x. And then go to your next power down, and that's the constant, no x term. That's right here. It doesn't have any others like that, so we'll bring that one down. Yeah, assume there's a 1 next to it if there's no number. Yeah, we assume there was a 1 here, add with the 9 for 10. Yeah. Yeah, and I recommend being systematic like that just to help yourself simplify your view as you look across, handle the third power terms, then look at the second power, then the first power terms, and then finally your no variable terms. Yeah, and so what we've seen about the parentheses is when we're adding, it doesn't really affect anything. Just drop them. When we are subtracting, then we need to change the signs on everything that comes after the subtraction. Let's look at some of the 10.2 examples where we're going to multiply some polynomials. First example being 3 x squared y times negative 4 x y. And let's assume for a moment that we were not told to multiply, or back here that we were not told to add. What's indicating that this is multiplication without knowing the objective? Yeah, those parentheses are just right next to one another here, whereas they had the operation specified between each other here. Okay. So this is implied multiplication, and I would suggest that you rewrite these terms so that the numbers are next to one another, like 3 and negative 4. The like letters are next to one another, so x squared times x and y times y. What's 3 times negative 4? Negative 12. And then the way we can treat these is this is like x times x, it's x squared. So x times x times another x, how many is that total? 3 of them. And so we can abbreviate that by saying x cubed with 3 as a power. Same thing here. How many y's? 2. So you have to visualize, and you can even write down if you want, x times x times x in another line. Got to visualize all the x's embedded in that power, and then plus this one. Right there over in the y's, all we have to do is count them up because they're both first power. Like having a 1 in front of them is what you're thinking. That's always implied. So if we didn't have a 12, it would be like this was 1x cubed y squared. With a number in front, you can assume it's that many of it. But yes, if we had ones kind of written down for ourselves as references, then 1 times negative 12 is just negative 12, right? But that is kind of implied there, or is a thing. Yep. Let's look at what else we have there. There's another example where we've got -2. I'm gonna have to go get another marker. Let's take a quick break here. Okay, let's look at that next example in 10.2 is -2x squared y times -4x squared y z all raised to the third power. I don't have the solution shown on this one. It was complicated to type out, so write this down for your reference. If we're going to multiply this times this having a power on it, we got to be careful to do this 3 times over first. So what I would do is just hold on to this by itself for a minute and look only at that. So 3 times those. 3 times them. There is -4x squared yz every time. -4x squared yz. -4x squared yz. There's some rules you can use to make this like faster, but just for your own understanding, getting it down confidently, I recommend to start with writing it all out like this. So then do like we did over here. Start bunching everything together, like -2 times -4, -4, and -4. Taking all of my numbers and accounting for them. Now let's take all of my x's. Got x squared from this one and from these. So times x squared, all of them have an x squared. Then I've got one y here. And 1, 2, 3 more y's here. No z's here, but 1, 2, 3 of them coming down from those 3 terms. 1, 2, 3. All right, now let's combine it all. 2 times 4 times 4 times 4, is that going to be positive or negative? Based on positive, we got even number of signs. And the result is going to be what? Take your calculator out and do that. What? That's 8, 32, and 128. Let's just verify on our calculator we've got that number correct. 128. And then once you have that verified, turn to your variable pieces. Each of these is like having x twice over. So if we imagined all of them, x times x times x times x, how many would we have? How many? 8. Yep. X to the 8. How many y's? Y to the 4th, and z to the 3rd. Good. Mm-hmm. So just combining all that, wrapping it up into one simple term with the powers accounting for everything we had that we brought into that line here. Questions on that one? Mm-hmm. This third power is not just like sitting on this z, it's sitting on the entire thing in parentheses. So that's why I'd recommend, as you're starting your understanding of this, to just go ahead and write that out that many times over. There are tricks, but I don't want to focus on tricks just yet. And let's focus on fundamentals like that. But yes, great question. And how do we recognize that as being applied to everything? It's because it comes after the parentheses. Here, this is understood to be to the first power, so we only need to write it once over. I'm going to do number 4 on the practice problem. It says negative xy times negative 2xy squared. So based on what we just talked about, what should we do first? Do what? Bring this down. Okay. Then what do we do with that? Negative 2. Want to do that twice over, right? So I'll write it not just once, twice over, then set myself up in a line so I can visualize everything that needs to be condensed together. So this is like a -1 here. -1 times -2 times -2. Okay. Then I have an x, and x, a y squared, and a y squared. All right. What's my sign here? What is it? Those two make a positive. I got another one here. So what's my final? Negative, negative, negative. 3 of them. We have an odd number of negatives. What do we do? What? You're thinking of addition. Just thinking of addition processes. London? Right. So with odd number of negative signs being multiplied together, the result is negative. You can think of it as London was just expressing these two make a positive and then times one more negative makes a negative. So we're going to have a negative result in the end. 1 times 2 is 2 times another 2 is 4. And then how many x's do I have? 3. How many y's? 3 written down, but there are more embedded in some of its powers. Uh, you were on to the right thinking. We have 2y squares. That makes 4 of them. And then one more makes 5. Yep. Think of these as counting over here. These are where the multiplication kind of lies. But over here, it's counting up. So 1, 2, 3, power 3 on that x. 1, 2, 3, 4, 5 for my power on y. So lastly, we're going to divide some. And let's start with the um, so there's one more thing I need to show you on multiplication. So let me backtrack a little here. Another example on multiplication. Oh yeah, 10(3) is about multiplication. I'm ahead of myself. 10(3) more multiplication, and specifically multiplication of polynomials. So let's look at negative 4x times 3x squared plus 2x plus, minus 1. That first example under 10.3. Got a negative 4x times all of this. So not just single terms like we had here. These were one term times another. This is one term times 3 of them. 10.3 first example. 10.3 first example. So this negative 4x is going to be distributed to all these terms. Here, here, and here. Why do we take that approach instead of like this times this times this times this? Notice these signs in here new. Plus, minus. We just have signs in front here, like this is a negative, this is a negative. Not terms lined up as if one is added to another and then another is subtracted here. That's how we determine the difference in approach. That this is going to be a distribution problem as opposed to just writing out multiplication like we did over there. So this term times the first one is 3x squared. Then the front term times the second one, positive 2x. And the first term times the last one, negative 1. Then we do each of these kind of like we were doing over there. Each of these is one term times another. So negative 4 times 3x times x squared. Here we have negative 4 times 2x and x. Here we have negative 4 and negative 1 times x. Negative 4 times 3 gives us negative 12. Then we count these up. 3. Negative 4 times 2, negative 8. Count these up. 2. Negative 4 times negative 1, positive 4, got 1. So this is reusing some of what we just talked about. The additional step here was distributing that negative 4x to each term. After that, we can think of it like we were doing before. What's that? Multiplying polynomials. The way you can look at this in terms of polynomials is this is a one-term one, a monomial, a one-term polynomial. This is a three-term one because it's got two operators here. 1, 2, 3 terms. This is a trinomial, a three-term polynomial. Over here, these are polynomials too, but it's a one term times a one term, two monomials. Because there's no plus or minus after this one. There's no plus or minus something after that one. That's why they're kind of like considered one term each, even though they have a bunch of stuff in them, right? This is one term, this is one term, this is one term, but they have operators joining them for 3 terms total in that polynomial. Look at the very last example in 10.3. You have some other ideas shown on that page with 10.3, but I want to highlight this example because this is the approach that I want you to try to adopt most. If we have that thing squared, that means we need to write it that times that. Okay? This 2 times over. Okay? We don't want to do any of this tricks. We want to stick with our spelling it out 2 times over. And then we want to say, okay, which terms are my first ones here? These two first. So the first product is 8x times 8x. And which ones are my outer outer here. On the outermost edges of your parentheses, think of it. So 8x and 3 are my outer terms. 8x and 3. And you may have already thought to yourself, we're doing what's known as FOIL method. First two terms in the expressions are 8x. Outer terms are 8x and 3. Inner terms, we move inside the parentheses here, 3 times 8x. And then last terms, 3 and 3. 3 times 3 there at the end. Then we go back and do our individual multiplications, similar to kind of this stage. So 8 times 8 is 64. X times x, or x squared. Plus 8 times 3, 24 with an x, plus 3 times 8, another 24. That one also has an x. And then lastly here, 3 times 3, 9. Then we want to ask ourselves, are any of these terms looking alike? Those two. So bring down our x squared, combine our x terms for 48x plus 9. Here we say 24 plus 24 for 48, and that's our x term. That actually might feel a little more familiar to some of you. If you did a bunch of those in class in the past. This one, I would say, is less frequently practiced in my history, but a little bit easier as far as doing it. Feeling okay on those last two? Any questions? Yeah, we're using FOIL here. And last. Yeah. And you can use your parentheses as the guide to that, like first, outer, inner, last. Yep. In 5, we're going to divide in polynomials. And let's take our example. A little bit of a correction I need to make there. It should say x squared. It just has a 2 in between x and y on that. Y minus 4x y plus 12x divide negative 2xy. Okay. So that's what we're looking at. Now, I would, instead of having it that way, encourage you to rewrite it so that this is underneath all of these terms. This thing you're dividing separate and underneath all of these. So let's write it that way. 8x squared y is my first term over here. Write it over that. Negative 2xy. Plus negative 4xy over negative 2xy. What did I do there? Put this term over the negative 2xy. Notice I also kind of forced it to be plus, and I put the sign with that. Just think that that's the better way of being consistent and not having to worry about signage over here. Because when we look to divide these, we're going to be asking ourselves whether they're two negatives or they're one negative. Okay, it's the easier view to do it that way. This last term already has plus there. So we're just going to write the 12x up here and the negative 2xy again on the bottom. So it's kind of like this divide became the fraction part of all these. Now, the reason that helps to write them all separately like that is we can start reducing on each individual one now. So what is 8 divided by 2? 4. And a positive divided by a negative? Negative. If I have 2 x's up here and 1 down here, how many do I have left? 1. Let me give you a visual of that over here. X squared over x. One of them divides away, leaving me with 1 left over on the top, which translates to just no fraction. If nothing's left on the bottom, we have no fraction. Y divided by y, they're gone. Okay? So that's all for that term. Negative 4 divided by negative 2 is positive 2. Positive because we got two negatives. 4 divided by 2 for 2. X's divide, y's divide. Same number of them. Last one, 12 divided by negative 2. Negative 6. X's go away. Y stays. But it's on the bottom. So just keep it down there. And you could have just as well written this plus negative 6 over y. Either way. Okay. You just have to have that negative once somewhere in there because it's once there. Just like here, once there. Twice makes positive. Dividing a negative by a negative. Let's do, I'm going to let you practice both of those that are on the sheet. Actually, you have plenty to practice online. So I'll write one of these. Number 1, 12x squared plus 6x divide 3x. So again, write each individual term over the divided one, like this. And then start simplifying each individually. What's our number in front here? 12 divided by 3. What do we get? 12 divided by 3, 4. Operate like normal division on your numbers. Then do a counting division here. I got 2 x's up here, 1 down here. So one of them goes away on top and bottom, leaving me with 1 on the top. And if it helps you as you're getting started, just write a 1 down there. If you don't have anything left over in the bottom, 12 divided by 3, give me 4. X, as I strike these x's, if that one goes away, and if I were to instead list these out for myself for that x square, then one of them is going away here. So technically, there's still something down here to hold the place. That's 1. However, since everything went away, the 3 went and divided with the 12, that x went away. There's a 1 understood down there. We're left with 4x on the top. That's eventually going to be simplified to just 4x. We don't need to write a fraction with a 1 on the bottom. Let's look at it that way again here. 6 divides with 3, right? Leaving me with 1 down here, 2 up here. The 2 over 1. And my x's got 1 in each place. So I don't have any to write down on either place. So I'm left with 2 over 1 there, plus 2. 2 divided by 1. So we've gone over all the sections from module 10. I just want to state for the video record what I want you to do by Monday, end of day, next week is complete those tests for module 5 and module 10.